My name is John Drake. On this project I worked alone. I named my tool ProtoJoint because the tool adds joints to a rigged character mesh to create a virtual prototype of an articulated model for fabrication on 3D printing machinery. ProtoJoint is a tool which could be used in multiple situations. A 3D artist might use the tool to create a posable maquette from a digital character model. The maquette could be used in subsequent design work, perhaps by animators, or for alteration with clay to test creative changes to the character design. The tool might also be used by someone wishing to create a toy, like an action figure. The output of the tool could be further refined by the toy designer, or it could be used directly. ProtoJoint operates on a rigged character mesh. In its current form, ProtoJoint uses artist-specified armature bones and bone sizes to determine which input joints to make physical in its output. It automatically orients joints and integrates them with the physical structure of the mesh. If the output appears satisfactory to the artist or designer, ProtoJoint can then directly output an STL format mesh file for use on standard 3D printing hardware. ProtoJoint exists in two parts. A Mel script manages Maya UI interaction and performs the joint placement and cutting operations. When the model file is ready for fabrication, the Mel script outputs a temporary Collada format file containing the mesh to fabricate. Then, the Blender 3D modeling software is invoked in background mode so the user does not see it, and a custom Python script handles import of the Collada file and export as an STL file which the user can find in the same directory. A third Maya C++ command plugin exists for additional automation, eliminating the need for artist specification of which joints to make physical, but it is not functioning in ProtoJoint at this moment. An additional Mel menu option exists to invoke this version of the joint placement procedure. The typical workflow for ProtoJoint is first to load a rigged 3D model. So here I have rigged 3D model. So here in wireframe mode, you see that I have selected joints at the ends of the rig. These joints have no children and they are automatically ignored by ProtoJoint. However, if the artist wants to ignore other joints, the artist can select those joints and then set the radius of those joints to be below an internal threshold, which is 0.1 right now for ProtoJoint. Or the artist can simply entirely zero out those joint sizes. It turns out that these most of these joints in here are already below the threshold, so I'm not going to worry about them. For joints that the artist does want included in the processing and for them to have a physical joint in the output, the joint has to be above that threshold and it should sit outside of the mesh. Its sort of spherical bounds should be outside of the mesh around where the joint is. So you see the leg joint there goes all the way around the leg and the neck one goes all the way around the neck. Next, to actually process the mesh and output a mesh that could be 3D printed, the artist selects both the mesh and the armature and then clicks the Jointify selected mesh by armature option from the ProtoJoint menu, and that places joints at each of the enabled armature joint positions, and then uses Boolean operations to cut and glue sort of those joints into the mesh. Then when the artist is ready to output an STL format file, which is the standard for 3D printing, there's an option in the ProtoJoint menu which takes care of that. So the artist just has to select the mesh, or it's already selected at the end of the ProtoJoint process, so then the artist can just choose that option, and it leaves a printme.stl file in the same directory as the Maya project.